Hello everyone to the computer science course. Today we're going to talk about the second unit and the first topic, computer architecture. It contains of 4 additional subtopics. It's CPU and its elements, RAM and ROM, the cache memory, and the machine instruction cycle. Today we're going to talk about all 4 of them. First of all, before starting, let's talk about what is a computer system. It's a system that consists of hardware and software components. So, as you could know, hardware is something physical, something that we can see and touch, that physically exists in this world, while software is most likely something virtual. And it follows the concept of input, process, output, and storage model. What does this concept model means? So here is its diagram. So a computer system accepts data or instructions as input, and data, so let's talk about each one separately. So input, so the data or the instructions are inputted to the computer system, then the computer system processes it, and after the processing it and turning it into the information, it could be stored and then used furthermore. And as the final its destination, it's getting outputted, the data getting output as information. So information is the processed data that is useful, that we can see and use and stuff like that. Now let's talk about CPU. It's the main part of the computer, and this process, like this model, happens in the CPU. And because of that, it's very mostly addressed as the brain of the computer, as all these processes happens in the CPU, Central Processing Unit. And its key definition is that it's a key component of a computer system, which contains the circuitry necessary to fetch, decode, and execute program instructions from and to main memory RAM. CPU has its own parts. The most main ones are control unit and arithmetic logical unit, CU and ALU, and it has many registers. However, the main ones that we need to remember and that is covered in this course are the control unit or the memory address register and memory data register, MAR and MDR. What is important, you should know all the abbreviators, so the short versions of the terms, because it's going to be examined. And for example, in paper, it could be asked what is CU, or what is the difference between CU and ALU, and stuff like that. So let's talk about each unit separately. So let's start from the CU. CU is like the boss. CU coordinates all the data and all the processes. It's in control of everything. It coordinates how data moves around. It handles the loading of new commands into the CPU. It decodes all those commands, and also directs data flow and operations of the ALU. And ALU is the guy who basically does all the operations. So CU tells him what to do, and he performs all the basic arithmetic, like plus, minus, multiplying, and division, and logical, like true, false, or input, output operations. And sometimes ALU is referred to a core, and hence computers with dual core technology have 2 ALUs to process 2 calculations simultaneously at the same time. Here is the simplified diagram where you can see how does all of this works. So processing happens here by the use of control unit and arithmetic logic unit. Now registers. Registers are very important, and there are the small storage locations that can hold data, usually a multiple of 8 bits. For example, a 64-bit computer has 64-bit registers. And the basic register in the CU are the memory address register, MAR, and the memory data register, MDR. As I told you before, they are the main ones, and they are usually considered to be the basic ones. So what is MAR? MAR holds the memory address of the data that is to be used by the ALU. So MAR knows where the data is located. it knows its exact address. And so furthermore, the ALU can fetch the corresponding content from the memory and process it accordingly. It may also hold the address of where the data that is processed should be stored. So as the processes are happened and ALU outputted made the necessary calculations, it's then by MAR is decided where it should be stored. And the connection bus is the wire that connects the CPU with the RAM, and the connections are accomplished by the memory address bus. You should remember these buses. And now MDR, it holds the data that is to be used by the ALU and then saved to the RAM. So MAR tells where it's located. MDR takes this information, and then ALU takes information from the MDR. And it's closely related to the MAR, since whichever memory address location the MAR is holding, the corresponding data will be loaded onto the MAR for processing by the ALU. So ALU, after it's done with all of these tasks, it sends the information to MDR, and then MDR stores it where the MAR told it to store. And after the processing has taken place, the ALU, as I told, places the results onto the MDR, and data is flowed to the primary memory. And the connection is accomplished by the data bus. What is very important to know is that you should memorize this diagram. You should know exactly what is where located, which bus is connected to what, and it's not necessary to know other registers, only MAR and MDR. However, you should know it because it 100% is going to be examined, and there will be a task that will ask you to draw this diagram. Now let's talk about the primary memory, this RAM primary memory. So RAM is the random access memory. It contains data and instructions the computer has loaded since starting up, and everything that the user has opened or loaded. It is volatile, which means that it loses its contents if power is lost. And it has the special link to the CPU by the use of these buses. And is often referred as a primary memory, so you should know that if in your examination paper or formative or summative you see primary memory, define it, you could know that it's often referred to the RAM, even though it's not the only part of the primary memory. And second one is the ROM, so it's read-only memory. Its contents were static, you could not change it. For example, in RAM you could change it, however in ROM it could not be changed at all. However, now you can change it. Non-volatile, does not lose its contents if power is lost, and it stores the BIOS, basic input-output system, a small program that allows the computer to know what to do to find the operating system to boot the computer after power is restored. So you should know the differences between RAM and ROM, because it's 100% will be the question where paper will ask you to name the differences, 3 differences between RAM and ROM. As you can see here, RAM is volatile, so it loses its content if the power is lost. ROM, however, on the other hand, don't lose its contents. It contains users' programs and data that has been loaded since booting up, and ROM contains the BIOS. RAM could be upgradable, it can be increased and upgraded and stuff like that. However, ROM could not be, because it's part of motherboard and it's very, very difficult to upgrade or change it. Now let's talk about the cache memory, the one that we saw here in the diagram. So cache memory is a type of small, high-speed memory inside the CPU. It used to hold frequently used data, so the CPU needs to access the much slower RAM less frequently. So what does it mean? That when the registers like MAR, first of all, when it checks the exact address location of the data, it first checks it in the cache memory to know if the data could be accessed more quickly, because RAM is very, very slow compared to cache, and cache speeds up the process. So this low quality picture information that you need to learn is the trend between the storage devices, like their speed, cost, and size. So CPU registers are the most fast ones, the most smallest ones, however the most expensive ones, and offline storages like tape drivers and etc. are very, very slow, potentially huge, however the most cheap ones. And this trend you should know because it's going to be asked and examined. Next ones are different types of RAM, SRAM and DRAM. So referring to its name, SRAM is static RAM, and it's type of random access memory. So it's not don't need to be refreshed. It's just static. It stays there, and it retains data bits in its memory as long as power is being supplied. And DRAM, dynamic random access memory, it's need to be refreshed all the time because the information should flow every time, and not the information, data, and is commonly used for the main computer memory. So DRAM are more preferred than SRAMs. You should learn their differences also. Computer science papers, they're in love with the differences, advantages, disadvantages, and stuff like that. So it's very important to learn their differences and similarities. So here are the differences. You can learn only 3 of them because mostly only 3 of them are requested. So yes. So the most easiest one, that static RAM do not require refreshing. However, dynamic RAM must be continuously refreshed. It delivers faster access time, it delivers slower, and you can talk about cost, that static RAM costs more than DRAM. So it's the most easiest differences here. Next, the final topic is machine instruction cycle. Machine instruction cycle describes the order that instructions are processed in a computer. Instructions are processed under the direction of the control unit in a step-by-step manner. So here is the cycle. As you know, it doesn't have its end, it just repeats and repeats. So here are the 4 steps of this cycle. Let's talk about all of them separately. So first of all is fetch. So instructions are fetched from the primary memory to control unit. The CPU is responsible for knowing which instruction it needs to take from the primary memory in order to operate correctly. To do that, it sends the appropriate address through the memory address passed to the primary memory. The instruction that resides in the specific address is then copied into the data bus and sent to the control unit CU. So as the instructions are here, as it's like arrived to the CPU, the instructions are copied and sent to the CU, so the data could be fetched. Next one is decoding. So the instruction that is fetched to the CU is now being decoded, so CU can know what is going on, what should be done. So instructions that has been received by the CU is then decoded. Decoding an instruction allows the CPU to be aware of any additional data that are necessary for the execution of the instruction. Any required data that need to be loaded from the primary memory in order for the instructions to be executable are then fetched. The address of these data are placed into the memory address bus, and the data from these addresses are received by the CPU through the data bus. Yes. Next one is execute the instruction. So the instruction should be performed. The CPU executes the instructions using the necessary data that have been loaded and calculates a result. Depending on the result, additional data may be needed. These data are fetched from the primary memory for further calculations. As before, the addresses of this data are placed into the memory address bus, and the data from these addresses are received by the CPU through the data bus. And the final one is storing. Store results of execution and check for the next instructions. After executing the instructions and computing the results, the CPU then restores the result in the primary memory, as you know, RAM. And to do so, it specifies the address where the results will reside in the primary memory, using the memory address bus, and sends the data through the data bus. The CPU then checks for the next instructions and repeats the steps described above by fetching, decoding, executing, and finally storing the result. Here is the diagram of how everything works. Here are the full names of terms that are now showed like abbreviator. I don't think that you really need this diagram just for you to know, because when it's asked from your examination paper to show how everything works, you can just show diagram like this and just describe these steps and instructions. So the materials that I would love to recommend is the KS Classroom. So this YouTube channel has all the course material for the computer science, and you can just watch it, and that's all. However, it doesn't contain all the information, because you should check your classroom as your teacher sent you some of the additional information will be checked, and also you should read the book. It's very important. The second one is the Computer Science Hub. It has also tips about what is going to be examined, and it has as well all the information stored as in the format of the presentations. It has all the information about IA, about extended essay, about everything. Very useful. However, it doesn't contain as well all the information that is in the book and that is going to be tested. And the number one of the recommendations is the Core Computer Science book. Please read it. It's very, very important, because everything that is written in this book is going to be 100% sure tested. And that's all. Thank you for your attention. Goodbye.